Alright, so in the last section we talked about how molecules interact with each other, but they're always the same molecules. You know, they'd be matching sets. And we're going to continue the idea of attractive forces here, and we're going to build on that, and we're going to talk about solubility. So we're going to talk about different molecules interacting with each other, and are they going to interact favorably or unfavorably? And before we really get into things, it's always good to kind of play the definition game a little bit. And there's three terms that are very key to this topic, and they all are very similar. So there's solution. Okay, a little different than what it means in math. There's like a math solution and there's a chemical solution. Not really the same thing. Same word, unfortunately. English is so versatile. We've got solvent, so solution, solvent, and solute. Like I said, I warned you, they're very similar. Alright, so we're going to define these. I'll show it in action. There's a couple more terms to show off in this video. This is kind of just our introduction. And so a solution is a liquid mixture. So if you're mixing together like sand and dirt, you're not making a solution, you're just mixing solids. This is a liquid mixture. And it's composed, you're going to love this definition, of a solvent, whatever that is, because we haven't defined it yet. So we got a solvent with solutes, at least one, maybe more, solutes dissolved into it. And I'll even do some examples in a little bit. And so the solution has to be liquid. You guys deal with solutions all the time, whether you realize it or not. You know, anything that's not just pure water. If you're having a coffee, that's a solution. There's a lot of other compounds mixed in with the water. Milk is a solution. It's a water-based solution, which, just like coffee, which actually has a special name for that category, which I haven't thrown on the paper yet, but you'll see it soon. And so it's when everything's, you know, mixed together. So it's a mixture in liquid phase. Alright, so solvent. So we've kind of got these two words have crept up in our definition here. Solvent and solute, which, hey, I've already got spots to define down here. So solvent is the component of solution that is present in the greatest amount. So whatever there's the most of. And there's one exception to that. And the way I think of the solvent is it's the thing doing the dissolving, whereas solute is the thing getting dissolved. But before we get into that too much, one note is that water is always considered a solvent. So if water is there, no matter how much or how little, water is the solvent. Okay? And again, it's the thing that does the dissolving. So what gets dissolved? Oh, that's the solute. So you know, it's whatever there's less of, or another way of thinking of it is the substance that is dissolved into another substance. And that substance that gets dissolved into, that's our solvent. Okay? And so, as an example here of a solution, I'm kind of in the process of moving right now, so my cupboards are a little bare. This didn't make the cut though, because who moves with vinegar? So this was still in the cabinet. This is a solution. So it's a water-based solution. So we have water as a solvent in here. And just looking at it, you couldn't tell the difference between it and water, but you can definitely taste it. And so what this is acetic acid, which is a carboxylic acid. We've talked about organic groups. And so vinegar. You've seen it in grocery stores. Maybe you use it in cooking or a recipe or something like that, you know. Well, what is it? Well, it is acetic acid dissolved in to water. And so what is acetic acid, right? Well, it's there's your acetic acid. Look at that, right? Line drawings didn't go away after all. So this thing is, we'll talk about how you can tell it's water soluble in a later video. But it is water soluble. It will dissolve in the water. We don't see two layers in here. It's all uniform. This is an even mixture. This is a homogeneous mixture, not a heterogeneous mixture. And so everything has dissolved. It was soluble. That's what we see. So there's a little bit of air bubbling around. Another example. I have a jar here with water, and then I've got a little container of sugar right here. And so water is going to be our solvent. This is going to be our solute. We put them together, and we get a solution. And so we can just pour it in, and at first it doesn't dissolve, but with a little stirring, hopefully I got enough water in there. Oh man, I need something to stir with. I didn't plan super well. There you go. Welcome to my office. Who doesn't have a drawer full of screwdrivers in their office, right? So we just stir it around, and it will start to be less and less, and it will dissolve. But yeah, it's only so many hours in a day. That's going to get attacked by ants later for sure. I'm sure of it. It's that time of year. Alright, so we just give a little swirl. And you can see there's at least a lot less sugar. If I kept stirring, this would have all dissolved. It wasn't past the point where it couldn't dissolve anymore. I know that. And so we've created a solution. So they have mixed together, and we have a solution. Any unmixed stuff, we can see there's some solid here at the bottom. A little bit. You can see it kind of over the letters. But if I keep stirring, that will help mix it. And so that's the solution. So the sugar was our solute. It got dissolved by the water, which was our solvent. And you put them together, solution. Again, it's a good thing those words aren't similar, so no one ever gets tripped up by them. But there's a couple other terms we want to talk about here before we close this video out. So if two things don't mix, like oil and water, which I'm not bringing oil in here. Yeah, get that on my desk. This is like a vinyl material on my desk, so that'll be getting cleaned up for years. But if they don't mix, like oil and water will not mix, you're welcome to try that yourself if you've never seen it before. We say that they are immiscible. So this means that a solution does not form. They do not mix. You might be able to stir them up, but then they separate again. The oil sits on top of the water. That's an immiscible solution. So there's no dissolving, and you see like distinct layers, distinct phases that are separated from each other. Whereas like with the vinegar, like I said earlier, we don't see that. You don't see like acetic acid sitting here and water over here. It's all spread out. They're all intermingled and mixed with each other. And not just because I was stirring it back and forth, but when I pull it off the shelf after it's been sitting there for, I mean, it's vinegar, so let's be honest, like 8.5 months, it's unchanged. And then the other term is aqueous. So you can have an aqueous solution. Oh, and before we get into that, so immiscible, the opposite of that is just miscible. So if it's miscible, they mix. If it's immiscible, they don't mix. Solution does not form. So aqueous means that water is the solvent. So for example, vinegar is an aqueous solution. Okay? So it's got water as a solvent, it's aqueous. What did I make in this jar right here? An aqueous solution. And most of that sugar is dissolved now. It's almost all gone. So we made an aqueous solution. Alright. So a lot of terminology, some examples to hopefully make it a little clearer. And we're going to start talking about, in the next couple of videos, we'll talk about how you can tell if something's going to be immiscible or if a solution's going to form. You know, we can get a good idea there. We're going to talk about ionic compounds in dissolving. And that's pretty much it, yeah. So it'll only be about 3 videos in this section. So Hopefully you're comfortable with these terms. You know, solution, solute, solvent. You know, what they all mean. They're very similar, but they have very different meanings. And we're going to be keying off of that for the next couple videos.